Hey guys, welcome back to the channel. Today we'll be modeling this impeller, and as of impeller is basically a rotating component of a centrifugal pump. So it basically transfers the energy from the motor that drives the pump to the fluid that is being pumped by accelerating the fluid outward. Alright, so very important component of centrifugal pump, and today we'll be designing this inside generative shape design. You can also utilize the wireframe and surface to do this as well. Alright, let's start with the design. So I'll go for a new component, go for part, press OK, and you can name the part as impeller. And after that I'll start with some basic sketch for the body of the impeller. So to do that I will start with the YZ plane, or make sure your workbench is either shape design or a wireframe and surface design. Okay, mine is shape design. So I'll start with the YZ plane, go to sketch, and I will start with a spline 3, 4 and 5 points, and then I will assign dimension to all these points from vertical axis. So this one and this one is already on the axis, so I will give this one a dimension from horizontal axis. Okay, once your sketch turns screen, that means it's fully defined. Now we will not use this value, so we will enter our own values, and to do that I will utilize the edit multi constraint, and let's say we'll start from this one. So let's say this could be 4, this could be 24, this could be 39.6, and this one could be 40, and then this one is 2, this one is 14, and then 30, and then last one 52. Once you have entered your desired value, you press OK one more time, and your sketch will become like this. So it's the value that we entered, and let's say I'm happy with it. I will exit the sketch now, and after that I will go for a revolute. So let's go for a revolve feature. I've already selected the sketch one. I will assign the axis as Z axis and the angle as 360. Okay, this is our body of the pump. Alright, now we will define one plane, and to do that I will start with the plane definition, and for the offset I will select XY. For the distance I will select 30 mm offset, press OK. Now what I can do is I can select sketch new plane, and then I will select the new plane, go for a sketch, and I will start with the spline again. Okay, then same with the horizontal axis. Once you have defined, your sketch will turn green, which means it's fully constrained. So now I will utilize the edit multi constraint and change the value to, let's say, 43.3, 36, 20, 11.8, 4, 5, 14 and 25. Press OK to confirm. Alright, so that's our sketch 2. Right, we can exit the sketch now. Now what can we do is we can utilize the project tool to project our sketch on the revolve, or you can say revolute. And to do that, we can either go from here, projection, and in the projection definition I will change the type to along a direction. I will say I want to project a sketch to. Support will be the revolute one, and direction will be the Z component. And if you preview it, you'll get a projection that looks something like that. Okay, now after that we'll do another sketch, and to do that I will select YZ plane, go for a sketch, and again we'll take a spline. We can do a spline like this. Okay, just 3 points. Go to constraint, then we can utilize the edit multi constraint to change the value. So let's say 40, this one is 10, this one is 4, this thing is 26, this thing is 36, and 50. Press OK 2 more times. Alright, so we have our sketch. We can exit the sketch now, and we will utilize another volute with the axis as Z, and it looks something like this. I'll press OK to confirm. Now I'll switch off the lighting a bit so that it's visible to you. Okay, I can also change the display style to shading with edges, and we have the boundary of our impeller. Okay, so now we can again go for the projection, and to do that we'll utilize the project, and in the project definition I will keep this one as normal, and projected should be the project one, and support should be revolute 2. Let's preview this. Okay, now we have the two projection. This is project 1 and project 2, and after that what we can do is we can give a line between these 2 points. Okay, so let's do a line from point to point, and select this point and this point and press OK. So now we have basically all the sketches required to go for the multi-section surface. And let's start with the multi-section surface. I will select project 1, project 2, and in the spline I will I'll come down in the spine and select line 1 as my spine. I'll press OK, and that's how the first blade is coming out. Alright, now we can do the smaller blade as well. So this one is the bigger blade, and to do the smaller blade we'll utilize the same sketch, which is project 1, and for that I will go to insert, advanced, I'll go to operation and use the rotate definition. Now in the rotate definition I will utilize angle, axis angle. For the element I will select project 1, and axis should be Z axis. I'll change, let's say 10 degree, and press OK. OK, alright, there we have the rotate one, and we can do the same thing for the other projection. So go to insert, operation, rotate definition. In the element I will select project 2, axis should be Z axis, 10 degree. Okay, now we have the uh, profile for the blade, and if you can see right now it's of the similar size, so it starts from here and ends over here. But for the smaller blade it should not be this much, so I will define some point and basically split this curve so that it becomes shorter in length. So let's go for point definition. I'll change it to on curve. Let's go for rotate one, and I'll change the length to 20. Can preview. Okay, I will do one more point on the rotate 2, so I'll select rotate 2 as a curve, and for the length I will type in 26 mm. Press OK. Now since we have these 2 points, we can utilize the split command to split the profile. So let's go for split, and in the elements to cut I will select rotate 1. Cutting element should be 0.1. Preview. Okay, that's what we wanted. Actually we wanted to eliminate the uh, full profile, and we just need this much of the profile for the small blade, and we'll repeat it one more times for rotate 2 with 0.2. Okay, now we have those 2 points, so we can go for another line, and we'll start from here to here. Okay, we'll repeat the multi-section surface between those 2 profiles. So I'll go for multi-section surface, split 1, split 2, and in a spline I will select this one as the profile. So now we have our smaller blade as well. Okay, so once we have our smaller blade, I will now assign thickness to the surfaces, because after this we will only need to make circular pattern for the blade and the design will be complete. So before that we'll switch it to part design, and here I will utilize thick surface, and we'll say, let's say go for 2 mm, and for the object to offset I will select revolute 1. Preview, we can go for the inside, and yeah, that's it. Alright, so we have a nice thick surface for the impeller. We'll go for another thick surface, and this time we will go for 1 mm with object to offset as multi-section surface, which is basically the bigger blade. And I'll press OK to confirm. We'll do it one more time for the smaller blade. So 1 mm for multi-section surface 2 as well. Alright, now from here we can hide the revolute, so I'll come and hide it. I'll hide the revolute 2 as well. I can hide the multi-section, and I can hide the other multi-section as well. In fact, we can hide all these sketches as well. So yeah, so that's how our model looks right now. Now all we have to do is pattern our blade, and to do that I will select thick surface 2 and go for a circular pattern. And in the pattern definition, I will change the parameter to complete crown with instances as 18 and reference direction as z-axis. Can press OK to confirm. That's the bigger blade. Now we'll do the same thing for the smaller blade. So select thick surface 3 and go for pattern, complete crown, z-axis as the reference direction. Right, so this completes the blade of the impeller. After that, what we can do is we can define a plane. So I'll go for a plane definition, offset from XY at a distance of 2 mm. Okay, and then I will select the new plane, which is plane 2, and go for a sketch, and I will select a circle, draw a circle from the center and give it a dia of 24, and we can exit the sketch from there. After that, we can basically go for a pad, and we go for up to next. Also, we'll utilize the thick operation over here with 3 mm as the thickness. If you preview it on the back, it should be like this. So this 3 mm is basically the thickness. If I turn it off, it will be a solid thing, but we want it to be a thickness of 3 mm, right? That's perfect. Now after that, what we can do is we can select this face and go for sketching, and here I will select this one, go for projection. Oh my god, select this face, go for a sketch, and I will just project this outer circle and make it for construction. Alright, and then I will select a line and draw a line from here to here, give it a dia of 7 point, not dia, basically the length of 7.21, and then exit. Now here we will utilize the stiffener. So we'll go to insert, we'll go for sketch base feature, and inside you will find one stiffener. And for the stiffener definition, I will say from top, and it automatically gives you a preview of the stiffener. We'll change the thickness to, let's say, 5 mm and press OK to confirm. Right, that gives a bit of support to the impeller plates. And after that, we can basically pattern the stiffener around this one. So I'll select the stiffener, go for a circular pattern, complete crown, change the instances to 4, and select the axis as Z, press OK to confirm. Right, and after that we need one more sketch, and to do that I will select this face, go for a sketch, select this circle, project it, and then exit. And then we can go for a pocket, and this time we'll go for up to last, preview. Okay, that's it. Now we'll do one more padding on this face so that it completes the overall model. And to do that, I will define a point first. So on circle sphere, this one, okay. And after that, we will define another plane with respect to parallel through point. Reference should be XY plane and point should be point 3. Okay. Then we can basically select the new plane and go for sketching. All we have to do is project this one. If I go for normal view, I can also project this one, but let's say I will select this one and go for offset of 4, and if I see the dimension 26, that's fine. Can exit the sketch, and from here I will utilize the padding in the reverse direction at length of 3 mm is fine. Okay, that wraps up the design of the impeller. Right? Nothing complicated over here. So if you wish, from here you can hide these planes, the default planes as well, and then you can go for apply material, and let's say apply some material. Okay, and then you can change some of the material rendering properties. So I go for diffuse, apply, can change the color to, let's say, here, make it more light. Okay, so that's how you can design your impeller in Catia V5. If you have any doubts regarding the design process, feel free to comment down below and subscribe if you're watching this. Also press the like button because that motivates me. See you in the next tutorial. Peace out.